Today we're going to be finishing our absolute value function and then working on compositions, which is a review from last unit. So let's start off with writing equations for these two graphs. So looking at the shape of this, we already know this is an absolute value function because it's in the shape of a V, right? So we know our parent function is going to be absolute value, which are these two lines, which signify absolute value. So just like with our other ones, we want to first start off with our shift. So what direction has this moved from the origin? So before it was right here, now it's moved 1, 2, 3, 4, 5 to the left. So if we've moved 5 to the left, that means inside for our x's, we're going to be adding 5 because it's the inverse. This is going to be x plus 5 inside here. Now we're going to pretend that this is my origin and see what has happened from my original. So I know my original is 1, 1, 2, 2, 3, 3. So my original function 0, 0, 1, 1, 2, 2, 3, 3. We want to see what has happened to go from this one to the new one. So right away I can already tell this has been reflected across the x-axis. Right. So that means that my y's have changed signs. So if my y's have changed signs, that means I'm going to have a negative outside of my absolute value. So all my y's have changed signs, negative, negative, negative. But even when my y's change signs, it's not going to be exactly where my new function is. So I want to see what else has changed. So what I'm going to do is find my new point right here. Okay, so before it was at 0, 0, 1, 1. Now it's at 0, 0. Let's look at this new point. So again, we're pretending this is our origin. So if this is my origin, if this is 0, 0, this one is going to be 1, and then 1, 2, 1, and then down 2, instead of 1, down 1. If I pick my next point right here, this is now, starting at my origin, 0, 0, this is now 2 over, down 1, 2, 3, 4. So look at what's happened to your points from your original to this one. So my x's have stayed the same. My y's have been multiplied by 2. So you can also kind of tell from the graph. If your y's have been multiplied by 2, it's a vertical stretch by 2. Because before this is at 1, your y was at 1, now it's at 2. Before this y was at 2, now it's at 4. So it's a vertical stretch in this direction. So if it's a vertical stretch by 2, that means your y has been multiplied by 2, so we want a 2 on the outside of my absolute value. And so this is f of x. Negative 2, absolute value of x plus 5. Okay, let's look at number 2 now. Same idea, we want to first start off with our shift. It's again absolute value function because it's in a V shape. Now here's my origin. To get to this point, it's shifted 4 to the right and 3 down. So 4 to the right means it's going to be x minus 5 in here. 3 down means I'm going to be subtracting 3 outside of my absolute value. Now again, my original function is 1, 1, 2, 2, 3, 3. Clearly this has changed. So again, let's pick the point. So this is 0, 0. This is what I'm pretending my origin is now. The next point I'm going to pick is the one that's going to be exactly on the line. So I need it to be exactly on the line. So notice right here, this one's kind of halfway in between. Again, it's halfway in between. This is the first point that's exactly on the line, both the vertical and horizontal line. So I'm going to use this point right here, and then I can also use this point. So just like when you're finding slope, you want the point to be exactly on the line, same thing. So now my new one is 0, 0. Instead of going 1 over 1 up, I'm going 1, 2, 3 over 2 up. Again, this is 0, 0. 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4 up. So look at what has happened to your points. Clearly both your x and your y have changed. So from here to here, my x's have been multiplied by 3. My y's have been multiplied by 2. So x's is it's a horizontal stretch by 3. Y's is a vertical stretch by 2. Right. So if your y's have been multiplied by 2, this is going to go, the 2 is going to go outside of your absolute value, so right here. With your x's, this is going to go inside the absolute value, but remember, parentheses around the x minus 5, because they have to be separated by a parentheses. And then we're not writing 3, it's the inverse, so we're going to write 1/3. And this is my function for number 2. Now we're going to practice this a little bit before we move on to the next part. Okay, so let's look at the next part. So now we're going to be bringing together some of the stuff we've done this unit and some of the stuff we did last unit. So our first step for these problems is going to be graphing this. So this is where I'm going to use 2 different colors. I'm going to first graph f of x, which right here, I can tell right away f of x is a quadratic function. So because it's quadratic, I'm going to be using 0, 0, 1, 1, 2, 4, 3, 9, and the same on the other direction. So this is my parent function, 0, 0, 1, 1, 2, 4, 3, 9. So this is 7, 8, 9. There's just 1 off the graph, so I'm still going to draw that there. And it's symmetric about the y-axis. So same thing on this side. It's an even function. So this is a simple one because there's only one thing happening to it. Minus 4 is outside the squared. So that means it's going to be shifting down 4. So all of my points are just going to be shifted down 4. So this one is 1, 2, 3, 4. 1, 2, 3, 4. 34. So these are my new points. I'm going to connect it with a line. And this is f of x. Yeah. So if you did it using your points, you could have also just subtracted 4 from each of your y values, and this would have given you your points as well. Okay, so now we're going to do the same thing with g of x. So I'm going to use a different color. So g of x, in this case, different parent function. These 2 lines right here tell you it's going to be absolute value, which is 0, 0, 1, 1, 2, 2, 3, 3. So again, my parent function, 0, 0, 1, 1, 2, 2, 3, 3. This is the v shape. Now there's a couple of different things that are happening to this function. So there's a negative on the outside, which means it's an x-axis reflection, which means I'm going to be flipping it across the x-axis. So now it's going to be a v pointing downward. It's also being multiplied by 2 on the outside, which means it's a vertical stretch by 2. A vertical stretch by 2 means I'm multiplying all my y's by 2. Right. So I made all my y's negative, and now I'm multiplying them all by 2. So now it's going to be 0, still 0, 1, negative 2, 2, negative 4, 3, negative 6. So instead of being at 1, negative 1, I'm vertically stretching to 2. The 2 becomes a 4. 3 becomes, a 6. Sorry, not this one. And then again, 2, 4, 6. They're all being stretched vertically by 2. And now my last step is just this plus 4, so I'm just going to be adding 4 to all my y values, which is a shift up 4. So each of these points is now just going to move up 4. 1, 2, 3, 4. So that's my new function. This is g of x. Again, you could have just added 4 to all your y's and plotted those points. Now to extend this on both sides, with your absolute value, these are just straight lines. So to finish this function off, it's actually pretty easy. For each of these, points are 1 over 2 down. So I'm just going to keep on going 1 over 2 down, 1 over 2 down. And that's going to help me draw the rest of my function, because it's just a straight line. Same thing on this side, 1 over 2 down, 1 over 2 down, because the slope is the same for all these. And so now I can just finish my function off on both sides. Okay, now that I have both of these drawn, this is just a blast from the past from last unit. I'm using the graph to answer these questions. So for number 3, remember this little circle is not multiplication, it's composite, which means I'm putting one function inside the other. So I'm going to find g of 1 first. So I'm going to go to 1 on my x-axis, find g. So g is the blue function. So I'm going to go up to this point right here, which gives me a y value of 2. And then I'm going to find f of 2. So I'm going to go over to 2. My function for f is the red one. So this is just this point right here, which is a y value of 0. And that's my answer for number 3. For number 4, I'm just subtracting f of negative 3 minus g of negative 3. So let's go to negative 3 on my x-axis. I'm going to find f, which is the red one. So I'm going to go up here. My function for f, the y value is 5. Then I'm going to subtract g of negative 3. So again, go to negative 3. Now I'm going to go down to the blue function, which is g. And at negative 3, your y value is negative 2. So 5 minus negative 2, this minus and negative becomes plus. So 5 plus 2 just gives me 7. Now let's do number 5. So g of f of 0. So go to 0 on your x-axis. We're going to go find f, which is the red function. So I'm going to go down to negative 4. So now I'm going to find g of negative 4. Go to negative 4 on my x-axis. G is the blue one. So I'm going to go down to this point, which is negative 4. And my y value is also negative 4. So my answer for 5 is negative 4. Now finally, we can find composition of functions graphically, like we used to. I'm also going to go over how we can find it algebraically. So this is actually pretty simple because a lot of it is just plugging it in. So algebraically, this little dot means the same exact thing. We're finding f of g of 1. So first what this means is we're going to plug 1 into our function for g. So I'm going to find g of 1. So my function for g is this one right here. I'm just going to plug in 1 for my x value. And we're going to solve this and find the number. So we're first going to take the absolute value of 1, which is just 1. And then multiplication comes before addition. So negative 2 times 1 gives me negative 2. Plus 4. Negative 2 plus 4 gives me a positive 2. And so g of 1 is equal to 2. So I'm going to take this 2 now and plug it back into f. So f of 2, so I'm going to plug 2 into my function for f, which is x squared minus 4. So I'm replacing the x with a 2. 2 squared, we're doing PEMDAS, order of operation, so exponents before subtraction. 2 squared gives me 4. 4 minus 4 is just equal to 0. And notice this is the same thing that we got for number 3. We just did it algebraically instead of graphically. Okay, let's do number 7. So now we're doing f of negative 3 minus g of negative 3. So let's first find f of negative 3. So f of negative 3 equals, we're going to plug in negative 3 into x. Negative 3 squared, so a negative 3 times a negative 3 gives me a positive 9. 9 minus 4 just gives me 5. So f of negative 3 is 5. Now we have to find g of negative 3. So we have negative 2, absolute value of x, which is negative 3, plus 4. When we find the absolute value of negative 3, it turns it positive. We have negative 2 times positive 3, which is negative 6, plus 4. Negative 6 plus 4 gives me a negative 2. So this is g of negative 3. So I'm going to do 5 minus negative 2, which is 5 plus 2, which gives me 7. And again, this matches with my answer to number 4, because it should give me the same answer. I'm just doing it algebraically instead of graphically. Okay, one last problem. Now we're going to do g of f of 0. So the first thing we're going to do is plug 0 into f. So I'm plugging 0 in for x. 0 squared minus 4. 0 minus 4 gives me negative 4. And negative 4 is what I'm going to plug into g now. So g of negative 4 equals, instead of an x, I'm going to plug in negative 4. So absolute value of negative 4 gives me positive 4. Negative 2 times positive 4 is negative 8. Negative 8 plus 4 gives me negative 4, and that's my answer. And yes, that also matches with my number 5 from the graph. So all three of these answers should match up with the ones from the graph. We just did it algebraically instead of graphically.